And welcome to Naughty Notes, the iSchool version for the pandemic of 2020. We're going to work on reflections here. You've got a quiz with 7 questions. We'll go through 6 of them as one's very much a repeat. In our textbook, this was section 9.3. But again, we did chapter 9 first, so it was early in the year. So dig back to September and let's see if let's review our coordinate rules. So I've got these up here, coordinate rules for reflecting across the various axes, and we'll just demonstrate it with a point first, and maybe take a picture of this with your cell phone, and you can use it as your notes. How about that? So let's take a random point. I'm going to call it 2, 5. Now, mind you, we could start in any quadrant, but we'll just do it the easy way. We'll start here. And look at the rule for reflecting in the x-axis. AB, A opposite of B. Well, 2, 5, and that's going to be 2, negative 5. So your point is going to go, whoo, it's going to flip all the way down there. That's a reflection in the x-axis. Let's take that same point, the 2, 5, and let's reflect it in the y-axis. AB, opposite of A, B. So it's going to be negative 2, positive 5. And we reflect like that. Now we've got 2 other axes to consider that are very common. We've got the x and the y as we've seen here. And now we're going to look at, how about reflecting over the line y equals x? Common there, the 45-degree line, 2, 2, 3, 3, 4, 4, 5, 5, negative 7, for example. That's a line that we're going to use a lot. And let's flip this over here and look at this. AB maps to BA. So I'm going to take my 2, 5, and I'm just going to reverse the x and the y, and that's going to be A-OK. And that's going to be 5, 2. Now the last one, I'm going to say that now y equals the opposite of x, or you might say y equals negative x. It's going to be down there. And I want to say I don't believe this one shows up in your iSchool, but it showed up in our class. So let's just have access to all of these. And we're going to say my original point, 2, 5, is going to go all the way over there. So 2, 5, AB, opposite of B, opposite of A. 2, 5, negative 5, negative 2. So take a pause there and take a picture, and you might remember this. You may need this. Well, of course you're going to need it. We've got 7 questions to get through. Well, let's get started. Ready? Snap. Oh boy, this is an interesting question. We're being asked where this, well, we can see what's going on. We can see the reflection. And again, the blue is the pre-image. The red is the image. For your monochromatic screens as your quiz, that means we are going to use the, well, those little apostrophes. We call them primes. The prime is the image of the pre-image. So S prime is the image of S. And you can see what's happening here. It's clearly reflecting across this axis, the vertical axis. But that's not really the question here. The question is, do you know the name of, well, do you know the equation for that? And let me show you something here. Now this is the line y equals x, for instance. This is the line x equals 1, right? Well, clearly we're not reflecting over that line. That's crazy talk. But this one, x equals 1, is a vertical line where all values of x are 1. 1, negative 5, 1, 0, 1, 7. They're all the values where x equals 1. The other ones, which you are probably more often confused about, oh yeah, the equation of the y-axis, that's the one we want. That's when it's going to be x equals 0. 0, negative 5, 0, negative 3, 0, 1, 0, 6, 0, 7. So that's going to be our answer. And really, what you want to know is that the equation of the y-axis is x equals 0. I know even the Algebra 2 students get confused sometimes. And that means that the equation of the x-axis, the horizontal one, think of it this way. That's the horizontal line. All the values of y are 0. 5, 0, negative 1, 0, negative 7, 0. So right there, keep this in mind. But if, in this case, we're looking for the vertical axis, the vertical or y-axis, x equals 0. Okay. All right. Let's move on here. Oh, now I'm nervous about this one because you're being asked to reflect this over the y-axis. And again, your problems may be different because there's a host of problems. So they will just be similar. And this, remember, this quiz is, or this review is to help you. You can't have the window open at the same time. So study this and then take your quiz. All right, I'll let you have 2 chances. I think all the teachers will let you have 2 chances. And I'm going to flip this over the y-axis. I left the coordinate rule there. And we know that it's going to end up looking like that. So this is not that hard. You're going to end up putting it over there. But now, let's suppose you're putting in a point. In this case, w prime, or it could be any of them. And I'm looking at, remember, x comma y. And that's going to be what, 6, negative 4. And it says you must include parentheses. Maybe we should just do this. So let's suppose we were typing this in. I don't know how it's going to look on yours. It says you must include a comma. Please put in a comma. I would probably put in a space here. I would put in the 6. And then it says, say you must include parentheses, comma, and a space after the comma. Heavens to Murgatroyds. I'm going to say comma, a space. Now, this is touchy software. And I'm going to put in negative 4. And then I'll close the parentheses. I don't know. Maybe you can put in another space. I don't know if that'll work. But that's how you're going to have to enter it. Honestly, I never write my quizzes with that kind of input. But I guess these folks in Florida know what they're doing. So go ahead and put that one in, and those are the 2 easy questions. Let's move on. Okay, finally, we are going to do something other than reflecting over the coordinate rules. Our 4 coordinate rules do not apply here. They do not apply at all. We're going to have to find a line of y equals 1. Now, you might remember if you took notes, this is y equals 0. This is x equals 0. Now, by comparison, this vertical line would be x equals 1. All the values along here. X is 1, y is negative 1, y is 2, y is 5. And by comparison, this is the line y equals 1. Y equals 1 is a horizontal line. So that's the one we want. Now you could even think of it this way. Y equals 0x plus 1 plus b, the intercept, is 1. So it's a line with a 0 slope and passing through the intercept, the y-intercept of 1. I don't know, maybe that helps. But you got to know that this one is the horizontal. And now, when we put our image in here, we're going to reflect. It's going to end up down there. And now we need to work on the very definition of reflection. And what that's going to mean, you can count, you can do arithmetic, but look at this. That point x, for instance. X, I look at it, it is 4 units above, and this means it reflects to 4 units below the axis of reflection. So you could just count them out, or you could do your integer arithmetic, and you're going to say 1 minus 4, negative 3 for the y. For the ordinate, the abscissa, of course, 1, 2, 3, 4. So it looks like it's going to be 4, negative 3. And you may have a different question, and you can see y here, or y prime. and that's looking pretty much like that's 5, -1, etc. So remember, this is the definition. A reflection, it's going to be, the object is going to reflect perpendicular to the axis of reflection and the same distance away. Think of it like that. You can solve any of these. Oh, okay. Take a deep breath. This is a big one. Oh, heavens to Murgatroyds. What we got going on here? Now, wow. And we're not going to label these vertices because this one, there's a lot going on here. First, I'm going to show you the visual, and then we're going to go through, maybe another method. Now, what we're asked, if I keep flipping this triangle ABC across different axes in different orders, will it flip back onto itself? Well, here's the progression for A. That's reflecting in the x-axis. Okay. Then I'm going to take that one and I'm going to flip it over the line y = x. Then I'm going to take this one and I'm going to reflect it over the y-axis. Yikes. And then I'll take that one a 4th time and I'm going to reflect that over the x-axis. What a mess. Now, you can see that that final triangle did not end up on top of the original ABC. So choice A doesn't work. Now, I'm not saying you're going to do this because I don't know how you're going to do all this. Is a lot of graphing. But that choice didn't work. Let's try choice B down here. X-axis, y-axis, x-axis. So x-axis, same reflection. Take that one, reflect it in the y-axis, and now reflect again in the x-axis. Makes a pretty picture, but it doesn't end there. Now, if it had one more reflection in the y-axis, it would have worked out, but it didn't. So B doesn't work. Okay. Now I suppose I could show you down here. Well, all I did, I'm going to take one of the points. I'm going to take the point B and take the first case, reflection in the x-axis, 2, 4. The coordinate rule, A opposite of B, 2, -4. Now take that 2, -4 and apply the next rule, y = x, -4, 2. You switch them. Then from there, you're going to apply the next rule, opposite of A, opposite of B. Oh my gosh. So that means the -4 becomes +4, the 2 remains. And finally, your 4th rule, and if you're following this, you're going to have 2 problems like this. This is going to take a little while. And from the 4, 2, we reflect in the x-axis. We look at the rule, A opposite of B. We flip the 2 to -2, 4, -2. Wow. Well, don't worry, we're going to do the last one together just so we can do one of these. But got to keep these videos under 20 minutes. So let's get cracking. Let's look at number 3, the third case. Reflect across y = x. Take that reflection, reflect over the x-axis, and then it says take that and reflect back over the x-axis. Well, then it's going to end up back over here. So, well, that ain't going to work. So choice Charlie is not it. And the last one, either that's it or we got a bad question. So here we go. Reflect in the y-axis. Take that reflection, reflect in the x-axis. Take that reflection, reflect in the y-axis. And of course, if you reflect one more time in the x-axis, you're going to end up right back there. So that clearly is the solution. And again, yours may be different. You're going to do this in this problem, and the next one you may do it with a hexagon. But try this out. Let's take the one point. I'm going to take the point B, and let's see how it travels through these transformations. The y-axis, and that's going to be A, or opposite of A, B. So that's going to be -2, +4. Now, wow, I lost my comma. And let's see, let's do the next one. So I'm going to take that point, reflect in the x-axis. So I keep the -2, and I flip the 4 to -4, okay? So that's the second reflection. Now we come to the third, the y-axis again. We take the opposite of the first term, so that's the 2, and we keep the -4. And finally, the last one, reflecting in the x-axis, the rule, A opposite of B, 2, and now I'm going to flip this, and it's going to be 4, and this is the only one where you start with 2, 4, you end with 2, 4. So go ahead and try that. If now, honestly, 1 point isn't going to guarantee that you have the correct answer. You might have to do a second point, and you got to go through all 4 possibilities. Yeah, these are terrible problems. I would never give you this, but you can do it. You can do it. So go ahead, crank through that, and honestly, it's kind of fun. If you have graph paper and you want to try drawing them, that's kind of cool too. But you're going to do a lot of drawing, so take a rest and. Well, okay, you're going to have another one like that with a hexagon. I fear that one, but we're going to skip that one. I'm going to let you do that one yourself. Let's go on to number 6. And again, the composite transformations. This is actually comes from section 9.5 in our textbook. Everything else was 9.3, but where we're going to do 2 different operations. First off, I don't like what the author said here, A, B, C, D. It really should be double primes because we're going to perform 2 different operations. So let's check this out. We're going to go through, we can go through, and again, let's take the point A. And what's it going to take to end up here at 3, 1? Well, let's try this one. I'm just going to start here at D, for instance. X plus 1, so -4. -4 plus 1 is -3. -2 plus 7, well, that's going to be 5. And then I'm going to say, the next one, I'm going to reflect across the y-axis. That's my rule up here, opposite of A, B. So that's going to be 3, 5. And clearly, that's the wrong place. That's not 3, 5. So we want to end up at 3, 1. So let's try this point. I'm going to take point A again at -4, -2. And by the way, these again are called composite transformations. Let's take that -4 and add 7. That's going to give me 3. Well, this is promising. And I'll take that -2 and add 1. And I have -1. Now I'm going to reflect across the y-axis. Now when I reflect across the y-axis, opposite of A, B, that's going to give me -3, -1. And that's not where I wanted to end out. I want to end up over here in the first quadrant. That looks like 3, 1 to me. So let's go this way. Again, I'm taking point A. I'm going to apply this rule. -4 plus 1, -3. And let's see, the -2 plus 7, that's going to give me a solid 5. And then I'm going to apply this rule in the x-axis where I keep this -3, -5. And again, failure. So, well, yeah, that's why I did start with A, because you know what's going to happen here. Let's try this. -4 plus 7. -4 plus 7 is, of course, 3. -2 plus 1 is -1. I apply my reflection across the x-axis where A, the 3 remains, and I toggle the sign -1 to +1. And heavens to Murgatroyds, you finally have the correct answer right there at 3, 1, because that's the point 3, 1. Now, if you wanted to see the actual transformations, it would look like this. And see, remember, this is, and we even used the code, the first image was in red, and then we would reflect it up there, and that we would use the double primes. So again, we're going to animate, we're going to slide it there, and then we're going to reflect it. And that is a composite transformation. In this example, it looks like A gave us the way. Okay, and we're going to end with one easy problem, and then you're done. Well, the authors just want to give you something practical looking, and so you've got this grid in orange. I've got the streets. I left the names off. We got the fire station in blue, and we're trying to make a congruent fire station. And it's going to be multiple choice. You're going to have two different choices for the coordinates of C and D. And really, all you got to imagine is this. You've got two different images. It could be there. And it does make a difference. Remember, A, B, C, D. They have to be in this order. You cannot go across. You can't go A, B across your heart, C, D. The C has to be down there. And the D has to be there below the A. So make sure you don't fall for that. And those of you on Sketchpad know better than that. That's one alternative. And your other alternative is up there. And again, this would have to be Charlie, and that's delta. So you've got two different possibilities. Those are the two different locations. And one of those choices, they will give you choices that suit one of those locations. And that's it. Thank you for building the fire station. And I hope this transformation quiz worked out all right for you. And thank you for watching Naughty Notes.